I want to show you something really cool in this video. We're multiplying two radical conjugates. Let's multiply this out and see the answer. The specific statement here is this answer is fairly unique to when multiplying radical expressions together. My first multiplication is 3 times 3, which is 9. I get a 3 times a negative square root of 7. This gives me negative 3 square root of 7. Now to the second set of multiplications, I have 3 times the square root of 7 is a positive 3 square root 7. The square root of 7 times the negative square root of 7 is the negative square root of 49. I want to make a note here. I actually could have written just 7 or negative 7 right there because the square root of 49 is 7. I get that these radical terms cancel each other out because I have a negative 3 square root of 7 plus and a positive 3 square root of 7. What I'm left with is this 9 here. The square root of 49 is a 7, so 9 minus 7, which gives me the answer of 2. This is a really strange answer. We got the number 2 when we multiply these two radical terms together. Actually, whenever you multiply two radical conjugates, you'll always get a nice rational number right here. These are considered irrational numbers, and it's rare that you multiply two irrational numbers to get a rational number. What really is going on? Well, if you remember, we have this formula for multiplying conjugate pairs together. The a plus b times a minus b is a squared minus b squared. That's actually exactly what we got right here. When we multiplied these together, we had these canceling these middle terms, but we ended up with right here, this 9 that we got, this was the first term of 3 squared minus 7. 7 is the square root of 7 squared. Let me backtrack and show you how I would do this with this property right here. So a quick way of multiplying these radical conjugates together is using this property right here. What I'll get when I do this, I'll get the first term here of 3 squared minus the second term of square root of 7 squared. The interesting part about this is that when I square then 3, I just get a 9. The interesting part is when I square the square root of 7, the square and the square root cancel each other out, leaving me with just 7 and giving me 2 as a final answer.